All right, so 2, 3, we continue with exponential functions. Again, today's focus is going to be a lot on their graphs and like how to find things out without actually going through the full graphing, like not plugging points, but just knowing characteristics about exponential function graphs. So what is an exponential function? It is a function with a base and then an exponent. The exponent is going to be where the variable is, somewhere there. It could be by itself or it could be obviously with something. The a in this expression or in this function is the base. And then the x is obviously the exponent. A should be bigger than 0, so a itself won't be negative, and it won't be 1. It can be a fraction, it could be a decimal, it could be something bigger than 1, but it won't be 1 itself because then that would be a constant line. So you might see something like a number on the front and then like 3 to the x, so it could be like -2, 3 to the x, where the very front number is negative. That can happen. But the base itself won't be negative, okay? We would treat that, so again, it could happen here, not here. You could see a fraction in there, you could see, or a decimal in there, okay? And we're gonna eventually start to talk about the difference between exponential growth and decay based on that base. So the graph of exponential functions take 2 different shapes. The first is exponential growth, and this is something that increases exponentially as I move from left to right. And then the other is called exponential decay, and this decreases as I move from left to right. Now what changes from growth to decay is your base is going to be greater than 1. So if my number here, so first of all, the A is on the front, and then B to the X if it's written this way. That's what it's using, your A and your B. Your B is going to be greater than 1 in order for it to have exponential growth. So here, positive, here, bigger than 1, and it would be exponential growth. If A is positive, but B is now a fraction or a decimal, and notice it's in between 0 and 1, so it's not even an improper fraction because improper would still be growth, then it would be decay. So this could be something like 3 to the x, and this would be something like 1/3 to the x, or 0.3 to the x. All of those would produce decay. Okay, example 1 literally just says, determine if the function is growth or decay and justify your response. So notice all the A's are positive because we're going to talk about what happens when it's negative in a little bit. But the thing that's being raised to the power is what we're going to focus on. So would a base of 0.75 produce growth or decay? Decay. Would a base of 2.3 produce growth or decay? Growth. And 7/6. Growth, right? It's a fraction, but it is improper. That's really 1 1/6, which would be growth. So this is my base is less than, well, actually it would be in between 0 and 1. Is greater than 0, but less than 1. Here, my base is greater than 1. And here, my base is also greater than 1. All of those produce, both the bottom ones produce growth. Example 2 says the following values are output values of an exponential function of the form f of x equals a times b to the x, where a and b are constants. Write the function along with the input value that represents the output value. God bless you. So first I want to identify like what is the one that's being repeated, because what variable is that going to be in this expression? If something is repeated, does it go where the a goes or does it go where the b goes? It goes where the b goes, right? Because that's what's being raised to a power. So in the expression that's there, 3 times 3 times 3 times 2.5, what am I going to put first? 2.5. It'd be 2.5 times 3 raised to the x power. That's what my expression would look like. And in this case, what is x? 3, because there are 3 3's. Go to B, which is the one that's going to be my base. No, good. My base would be 0.3. The thing that comes first, or the A, would be 3.5. And 0.3 is raised to the x, and in this case, x is, again, 3. Questions so far? You could literally see an AP question that says, take this expression and match it to one of the A, B, C, or D, like multiple choice, and you just have to rewrite it in exponential form. Yeah.
Are there going to be any questions on a test like that?
Possibly. I'm still working on your test, but it is possible. You definitely didn't see it in the homework. Yeah.
When you say base, that's which number?
Base is the one that's being raised to the exponent, so the base is B.
Okay.
Yeah. All right, characteristics of exponential functions. Exponential functions are either always increasing or always decreasing. It cannot change within one expression. So if I use an exponential function like this, it is always increasing. And if I had an exponential function that was falling as I move to the right, it is always decreasing. So that does not change direction, which means there's no extrema. There's no maximum or minimum point. The graphs are always concave up or concave down, which means there's no inflection point. So remember your U's and your N's, right? This would be concave up. This would be concave up as well. If my graph flipped upside down, now it would be concave down. So this one is down, and these two are both up. All right, and then the third thing says if the input values increase or decrease without bound, then the end behavior can be expressed as a limit. Think about what these possible scenarios could be. If I look at this first one, okay, the first one I drew, this guy up here. If I was talking about the limit to negative infinity, what's happening to my graph? It's getting closer and closer to what? If it's going here, it's getting closer and closer to what without crossing it? 0 without crossing it. So one of the things that it could be, your limit could be approaching is 0. If I'm going to the right or I'm approaching positive infinity, what does that happen? What's the limit there? Positive infinity. And if I were to look something at like the one I drew down here, what happens as I approach positive infinity there? It goes to negative infinity. So your limit notation will result in one of these three things unless there's a vertical shift. These are all based off of your original parent function in which there is a horizontal asymptote at 0. Obviously, if that moves, now it's not just 0. It could be wherever the horizontal asymptote is. But if not, if there is no vertical shift, then my answer for the limit will be one of those three things: 0, infinity, or negative infinity. All right, so now let's look at some graphs. Now the goal is to know what it looks like without actually having to plot points, but obviously if you are stuck, you can always go back to plotting points to figure out what this graph looks like, okay? But think about what we just talked about. If I looked at this graph, what is the base on it? 3, and 3 is in between 0 and 1 or bigger than 1? Bigger than 1. The term on the front is positive, so I'm not flipping anything upside down. I'm literally just taking my exponential function, which would be above the y-axis, the x-axis, and it would be increasing because it has exponential growth. So now, is this function increasing or decreasing? Increasing. Is it concave up or concave down? Concave up. What is the limit as it's approaching negative infinity?
0.
Thank you. Good. 0. And what is the limit as it's approaching positive infinity? Positive infinity.
How do we know that it has a asymptote at y?
Unless there's a vertical shift. So if you see plus or minus something after or separate, that's going to cause a vertical shift, which moves your asymptote. If not, which most of these will not. it will be 0. Tomorrow, we're going to talk a little bit more about what happens when I start to shift these things around. But for right now, there's no vertical shift. And if there's no vertical shift, it's at 0. All right, go to 4. What changed here? There's a negative on the front. What does a negative on the front of my function do? It flips it upside down. This is a reflection over your x-axis, okay? The base is still bigger than 1, so this would still have exponential growth, and then I would flip it upside down. So it would start this way, and then if I flip that upside down or over the over the x-axis, it looks like that. So this is my ending graph. Is that increasing or decreasing? Decreasing. Is it concave up or concave down? Concave down. What's the limit as it approaches negative infinity? 0. And what's the limit as it approaches positive infinity? Negative infinity. Easy stuff, right? Test question. Promise you. All right. Now what's different? It's positive on the front, but what's true about my base? It's decaying, which means that it flips the direction. It falls as I move from left to right. So is it increasing or decreasing? Decreasing. Is it concave up or concave down? Still concave up. What's the limit as it approaches negative infinity? Positive infinity. What's the limit as it approaches positive infinity? 0.
Can you go to the last slide?
Mm-hmm. All right, so here's your vertical shift. If there is a function plus or minus something, this would cause a vertical shift, okay? We're not going to do too much with it, but there's a question on the homework tonight that you have to understand this, which says, if the output values of G, which is after it's shifted, if the output values of G are proportional over equal length input values, then F is exponential. So if my shifted up or down has proportional values, then my original has to be exponential. But it does not have to happen in reverse. So if I'm looking at the one that already has the shift, this has been shifted up or down, and that is proportional, meaning that y2 over y1 would be the same as y3 over y2, right? I'm multiplying by the same thing each time. Then I assume that F is exponential. But just because F of x is exponential does not mean its shifted graph will be proportional. So this is true in the way that, again, it's listed. If the shifted is proportional, then the original is exponential, not always the other way around. So if the shifted one is proportional, then I know the original is exponential. If the original is proportional, the shifted one might be exponential, but it might not. Questions? That's it, people. It's the whole lesson. Yep. Function. It already told you it's exponential, right? So I know that my ending equation is going to be like a y equals a b to the x. I have to figure out what the rate of change is. So I have what are disguised as coordinate points, but this is saying that n is 8 and a8 would be 12. And this is saying n is 10 and a10 would be 6. So if I want to find my r, my common ratio, then I take the one with the bigger base, I put it on the left. So A10 would go here equals A8 times R to the difference between those two, which is squared. So then 6 equals 12 times R squared. And I want to divide by 12. R squared equals the square root of 6 over 12, or 1/2. Yep. Okay, hang on, let me get through these first. Okay, so that's my R.
Okay.
So now I can use either of the points they gave me to make an equation. One is if I start with 8, right? Then I can say A of n equals A of 8, which is 12, times R, which is ugly, but it is the square root of 1/2, to the n minus 8. That number should match the number of term.
Okay.
Or I can use 10. AN equals A10, which is 6, times the square root of 1/2 to the n minus 10.
I'm guarding wrong if I put it root 2 over 2.
No, it came up in like one of the videos I was watching. They said, look at your answers first. If it's multiple choice, it probably will not be rationalized. And if it's not rationalized, they will still give you credit because it's equivalent. So is it wrong? Certainly not. That's usually how we train you to do it. But they will not take the points because it's equivalent. Yeah. All right, so do you want me to do the next one?
No.
You're good on that one. Okay. All right, so
Any
first
other
of all, the directions here told you it's an exponential function. This is when you guys were like brain fried early in the morning. Like you guys, it was like talking to zombies yesterday. Exponential function, and you have to find the equation. So first of all, given these coordinate points, I have to figure out what my R is, right? The way I figure out the R is these are coordinate points, but really this is saying A is 3, so then A base 3 is 5. And this is saying, not A, N is 3. N is 8, so A base 8 would be 40, right? So even though they're given in coordinate point form, I can transform them into geometric sequence terms. So if I want to find R and I have jumped terms, I've gone from 3 to 8, then I put the bigger base on the left, the smaller one goes on the right, and the exponent on the R is the difference between the two. So this would have to be to the 5th power. Okay, so A8 is 40, A3 is 5, and then this is R to the 5th. So then I would divide both sides by 5. R to the 5th equals 8. And R is going to equal the 5th root of 8. And I'm going to keep it exact, so I literally leave it like that. It's not pretty, but that's what R is.
So how did you get the 1/2 that you had before?
That's 12.
Oh, that was
Yeah.
12. Oh, okay.
Yeah. So now that's my R. Thank you. That's my R. So I have to figure out an equation. And there are two options. One is using my N as 3. So AN would be A3 times R to the N minus 3. The base on this has to match what you're subtracting from up here. So AN could equal A3, which is 5, times R, which is actually the 5th root of 8, raised to the N minus 3. That's one acceptable answer. The other is use 8 as my term. So AN would equal A8 times R to the N minus 8. Again, these two have to match. So AN equals A8, which is 40, times R, which is the 5th root of 8, raised to the N minus 8. Either of those two answers would work. Yeah.
Question 12. I really like that.
All right, 2 says, when a certain car is initially purchased, its value is $20,000. If the car loses 9% of its value each year, when will the car's value be $10,000? I actually set up a decay function, and then I tested by plugging in points from what they gave me. So if you're starting with $20,000 and you're losing 9% each year, then what you have left is 0.91, right? That would be that 100 minus the 0.09. And then we don't know what x is supposed to be. So I literally took that function because it said I could use my calculator. I literally took that function and I plugged in 1 to see what it would be like. And then I plugged in 2 to see what it would be like. I plugged in 5 to see what it would be like, 6, 7, and 8. And it happened at 8, right? At 7, it wasn't 10,000 yet. But at 8, it was already less than 10,000. So I knew it had to happen in between that time frame. Yes. So it said They needed to build a shovel. Oh, because you can't buy a partial of a shovel, right? So like it said, it was a combination between what was it? Shovel for S dollars and the cost of one plant is P dollars. So my shovel was literally that cost plus the P times the number of plants, right? Which even if you had made X initially would have worked like that. But then when you went to your answer choices, it's the realization that it's not exponential. I knew that one, like that one got ruled out. It's not geometric, that one got ruled out. So now I'm between linear and arithmetic. But a linear function is continuous, which means it would have all the points in between there. Does that make sense? And with a shovel, you can't buy a part of a shovel. It's either you buy the shovel or you don't, right? So it was more single dots, which is why it's arithmetic instead of linear. Other questions from the AP questions? Edward.
Did you go over number
5? Is that a question?
Hold on.
Are you sure? So your initial function for an exponential is a1 times r to the n minus 1. That is your parent function. And so if I have 1, that is a1, right? So a1 times r, and then n minus, this always matches the base, like whatever number term it is. So if 4 is my a1, and then I found the r, or they gave you the r to be a half, then the exponent has to be n minus 1. If the x was 0, now you wouldn't have a 1 after the n. Does that make sense? So no matter what the r is, no matter what the a1, whatever the first term is, whatever number is on the base of that first term that you're using is what you're taking away from n. So if I had a2, it'd be a2r n minus 2. If I had a3, it's a3r n minus 3. Whatever you're subtracting should match the initial term's base. Who said 6? Wait, that was you?
Yeah.
So it said the second term of the sequence is 6. The fourth term of the sequence is 24. So second term, right, A2 was 6 and A4 is 24. And it said, which of the following statements is true? So I don't know if it's arithmetic or it's geometric. So I tried to figure out if it was arithmetic, what would be my sequence. So if it was arithmetic, then it'd be 24 minus 6 over 4 minus 2. So it'd be 18 over 2, which is 9. That would have been D. And my expression would have been this, AN equals, I'd have to go back if I went back to be negative 3. Because if this is A2, then subtract 9 from it, and A1 is negative 3. That sets up my AN. And then if it's arithmetic, it said the third term could be 12, so I plugged in 3 first. Oh, that was on the other page. And I didn't get 12. Negative 3 plus 9 times 3 minus 1, which is negative 15. It's positive 15, so that one was wrong. And then if I plugged in 6, which is this one, I got 42, so that one was wrong. That meant it couldn't be those two, which is eliminated arithmetic. So then the next thing I would check to see is if it's geometric. So with bases of 2 and 4, I would do A4 equals A2 times r to the second. A4 is 24, A2 is 6, r to the second. This is 4 equals r squared, and r would be 2. So my function, if I wanted to find the first term, I'd have to either go backwards from the second term. So if the second term is 6, I would divide by 2 to get the first term, which would have been 3. So that ruled out that one. Or if I want the fifth term, I could go forward from the fourth term by multiplying by 2. And if the fourth term is 24, 24 times 2 is 48, which is where that one works. God bless you. Other questions from AP or the PDF? Yes?
I have a question
Okay, so this means the 0.8 means it's decay, right? And then the negative on the front means it's upside down. Why did I just do that way? That way. So this is the graph. It would be increasing, yeah? And it'd be concave down, negative infinity, positive infinity, 0. Steven?